Here's another nice acid-base demonstration, and equilibrium and kinetics. I have distilled water in there, and what I'm going to pour in, milk and magnesia, which is basically magnesium hydroxide. It says right there, magnesium hydroxide. So I'm going to pour some of that in there. Magnesium hydroxide will not dissolve well, dissociates, but will not dissolve very well. What I'm also going to do, because I'm going to show you a neutralization reaction, in the grand scheme of things a neutralization reaction, but we have to get to that point. We'll throw in some ice, because of course what does ice do to a reaction? Slows it down. So what we've got now is a nice slurry of a very basic solution. I'm going to put in some universal indicator, and it's going to go a lovely shade of purple. And I think just a smidge more. Universal indicator is one that'll do the whole gambit of colors from red, very acidic, to violet, very basic. So what I equate this to is girls and boys. So right now, what I got in there is an analogy of a whole bunch of girls floating around in there. Those are my hydroxide ions. I got all these girls in there. What I'm going to do is, with hydrochloric acid, which is a strong acid and dissociates 100%, my hydrogen ions are going to be the boys. The boys are going to date the girls and remove them from solution. So I'm just going to pour in a few boys at a time so that the girls are in excess for a while. So I'm going to throw some boys into the solution. Watch what happens. Alright, notice a whole rainbow of colors. When I initially threw in my acid, my hydrogen ions, aka the boys, it went very red because it initially saw these hydrogen ions and said, oh my gosh, an acidic solution, and it went super red. Then, as equilibrium started to establish, those hydrogen ions met up with the hydroxide ions and formed water. So you saw the change from a very acidic red through the orange, through the neutral, now back to the purple, because of course I only threw in a few hydrogen ions. So there's still lots of hydroxide ions in there waiting for their chance for the hydrogen ions. I'm going to throw in a little more ice so we can slow it down. Alright, so here I'm going to throw in a few more hydrogens. So now the hydrogens we said were the boys, right? So I'm going to throw in another handful of boys into this room full of hydroxides, the girls. Goes to pink, that's very acidic. It's a shock to the system. There's our yellow, blue. Here's our seafoam green, if you will. Going into the neutral range. The hydrogens and the hydroxides are coupling up. Notice that we're going into still the basic range of the universal indicator. That means I still have lots of hydroxides, excess hydroxides in there. I haven't matched them all up yet. Back into the purple range. Now I'm going to do the same thing again. Pour in a little hydrogens. It's shocked, it goes into the red. Now you see the yellow forming on top. Now we're going neutral. Let's see if we have hydroxides left over. Equilibrium gets reestablished. We're going back into the violet range. Not as dark purple as earlier, So we still have some of those girls, single girls, floating around waiting for their chance to couple up. Gonna throw in some more boys. Gonna throw in some more hydrogen ions with my 6 molar HCl. Notice the red staying around a little longer. Okay, so now we're going into the yellow, green. Alright, so we're in the green range. That's pretty close to neutral. Notice also how clear and colorless, or clearer it's getting to be. Let's do pH. We are at about neutral here, 7 pH. Neutral solution means all my hydroxide ions are gone. All the hydrogen ions are gone. I've got water in there, and it's a very neutral solution. All right, what I'm going to do now is I'm going to toss in too many boys. So all the girls are technically coupled up. Now I'm going to toss in too many boys. Now let's see if anything occurs or if it just stays very acidic, because I've got an excess of hydrogen ions now.